This is Performance Time, the show about human beings and performance engineering. I'm Stephen Townsend. Welcome back to Performance Time. It's good to be back after taking a couple of weeks break. I travelled down to the South Island of New Zealand where I celebrated my 10-year wedding anniversary with my wife in Christchurch. Went whale watching in Kaikoura, and then I did something that I've never done before. I stayed in a batch, which is a Kiwi word for holiday home, by myself for 5 days in the middle of nowhere. I had this idea that being by myself without any kind of connectivity to the real world would be revitalizing and give me a chance to take a breather. But what I didn't realize is that I actually had cell phone reception at the place I was staying. So it wasn't quite the holiday that I expected it would be, but it was still a pretty awesome experience and very much needed. I do want to acknowledge that I'm incredibly lucky to be able to do this at this time when COVID is absolutely rampant in some parts of the world. So I'm very privileged to be able to do that. Today I'm talking about performance testing and the test data that we use. So test data, I think, for load testing, is a completely unique challenge because of the huge volume of data that we require. So for functional testing, we might need dozens of records, maybe hundreds at most. But a load test, it might often need tens of thousands, hundreds of thousands, maybe millions of rows of data just for one data pool. And the other thing about load testing is that they can create and delete vast quantities of data dynamically as they run, and that all needs to be managed as well. Now, I still face challenges with performance test data fairly regularly, and I'm meeting other people who are hitting similar issues to myself. So today I wanted to introduce some of the specific challenges around performance test data, and then how we can either solve those problems or at least alleviate some of the challenges. Now, test data is one of those things that can create a lot of technical debt. So what I mean by that is, if we're not careful, it's going to take a lot of time and a lot of trouble to maintain our test data as we move forward. Now, that's a deal breaker if your intention is any kind of continuous or automated performance testing. There's a danger that if managing the test data is too much work, you might discourage teams from doing performance testing in the first place, which is an absolutely terrible outcome. On the other side of the coin, there's plenty of load tests being run without enough thought being put into the test data and whether or not it's going to produce a meaningful result. For example, not considering server or client-side caching, producing unrealistically quick or slow response times. There needs to be a balancing act between the realism of our test data versus the cost to source and maintain it. It's about finding that sweet spot in the middle for each of the systems that we test. Okay, the first challenge I want to talk about is about the load testing tools that we use and the test data management services that they provide. So there are a few features relating to test data that I think you absolutely have to have available, but funnily enough, not every load testing tool supports all of these. For example, I like JMeter, I use it all the time, but the out-of-the-box CSV dataset config, it doesn't support consumable data, adding new records of data to a data pool dynamically, or even randomly accessing a record without installing third-party plugins. In the organization that I work for, there are 3 different teams who all use JMeter. They've hit the same challenge, and they've ended up in isolation creating their own test data platforms outside of JMeter. So there's obviously a universal challenge here with JMeter, right? It is worth mentioning that there is a plugin called the Simple Table Server, or STS, which supports all of the features that I just mentioned. And I actually modeled my own test data platform off the STS. I'll talk a little bit more about that later. So let's go back to those key features which I think that you need in your test data platform. First of all, consumable data. So this is when you have a record of data that can only be used once. So you need the record to be deleted from your data pool after you've used it. So as you know, I work in insurance, and a pretty common business flow for me is to take an insurance quote and to buy or bind it into an insurance policy. So once I've done that, the quote number that I used no longer exists or is invalid. So I need to remove that quote number from my data pool. So that's consumable data. Adding new records to a data pool during a load test is another feature that you will need at some point. So going back to my previous example, I might run a test in which one script creates insurance quotes and then adds the quote number to a data pool. So that's the adding dynamically part. And then another script consumes those quotes in order to bind new insurance policies. Lastly, and it's not necessarily compulsory, but I like to have the option to read a random record of data from a data pool and not always read each record in sequential order. I have a feeling that this is one of those things that some people have really strong opinions about. So all I'm going to say is that this is a feature that I like to use in certain situations. I'm a pretty big proponent of open source, but I will say you are more likely to get these features built into a commercial tool than you are in an open source one. To work with open source, you might need to build something yourself to handle test data outside of your load testing tool. In saying that, just because a tool is commercial doesn't mean it will support all of these three features. The important thing is that you know what test data features that you need and whether or not your tool supports them. The next challenge is, where do you get your test data from? Depending on where the data comes from, how often it changes, how many dependencies there are within the applications you are testing for this data, this will probably be significantly more complicated than managing the test data during a test. So here's some examples of different sources of data. Firstly, there's test data that you create yourself before a test starts. For example, user accounts. You might have some script to create the accounts and to store the details in a data pool for you. Then there's data that you create yourself, but during a load test. For example, the insurance quotes I talked about in the previous example. I would have a script, and as it's running, it is logging the quote numbers of the successful quotes that are created to a data pool to be consumed by some other script. Then there's data that you query from the system under test. So I work with many load test suites which rely on retrieving data from a database using a SQL query. For example, I might query a database to retrieve a list of active customers in a particular system. So in one environment I work in, the databases are refreshed with masked production data pretty frequently. So I need to rerun this query to get my test data pretty much before every performance test that I run to make sure that I have up-to-date data. There's also population data that is validated in some way. For example, valid addresses for the country or countries you are working in, vehicle registration numbers, those kinds of things. These can be a bit enigmatic to get your hands on. For example, I once got a series of valid New Zealand latitude and longitude coordinates from a government website. And I got them and I still use them because they still work, and often this data only needs to be sourced once. You don't need to very frequently update it, and so it can be pretty low maintenance. The next one is a little bit strange, but it's something that I found myself doing quite often, and that's using trial and error in a system under test to find valid test data. I don't know if anyone else does this or not, but I wanted to talk about it. So recently I was having real trouble getting valid addresses for a particular system. So this particular system had a screen, it was a web application that you could go to, and you could start typing in an address and it would give you hints or suggestions of valid addresses that match that, whatever you've typed in, right? So I wrote a script which would go to this page. It would type 2 random numbers followed by a space and then 2 random letters. And if any suggestions came up, it will log all of those valid addresses to a file, which I then turned into a data pool. Now, this is sort of like a last resort kind of option, but sometimes you just got to do what you got to do. And I'm interested to hear if anyone else has turned to this kind of quick and dirty approach to getting some valid test data. The last source of data I wanted to talk about is when you generate some kind of data using a script or some kind of logic or function. For example, using a function to generate a random date of birth for a customer that you're creating, or a random first and last name, just a bunch of random letters, for example. Now, this is really nice because when you do this and it works, you don't have to maintain any data. You just build some logic and let it do its thing. But you do have to make sure that you really understand the solution under test and the implications of using fully randomized data. For example, if you randomly pick a product from an online store, you will be changing the caching behavior of the website. In the real world, customers will predominantly search for and view a smaller set of popular products most of the time, right? And they're the ones that are going to be cached. But if you randomly choose any product at any time, then it'll be less likely that the product that you're searching for is already cached in memory when you request it. The challenge I'm talking about here really is knowing where to get the test data that you need in each situation and what data you exactly need. And then there's the overhead of the additional process or people or tools that you now rely on to get that data. For example, maybe you need to write some SQL queries to get valid test data, and the database is one you've never used before. So you have to learn about a particular flavor of SQL and get access to the database. You might have to learn about the table structure of the application under test. And all of this takes time and it takes energy. And the more work there is to do to source your test data, the more risk there is that you're going to build a bunch of technical debt in the way that you are performance testing, and that will hurt you later on. The third challenge I wanted to discuss is that something that can be really challenging is knowing which data you need to handle dynamically and which you don't. For example, do the names of the customers that you create matter? They might if there's some kind of search that uses the name as a filter, but you won't always know this up front. What about an application which has a bunch of dynamic IDs in the form post parameters which don't seem to change between recordings? Is it safe to leave them static in the long run? You can't always find out that kind of information from developers either, especially with off-the-shelf products when often nobody really knows much about the HTTP traffic at all. Okay, on to the fourth challenge. So whether you are retrieving your data from somewhere or generating it yourself, make sure you understand the conditions in which that data expires, if it ever does. So using the same example as I used before, let's say that I have a script which creates insurance quotes. Now, quotes expire after 30 days, at which point they are invalid and you can't bind a policy from them. So if I add these generated quote numbers to a data pool and they're not consumed or removed within 30 days, it's going to cause my test to fail. This actually happened to me pretty recently. So I had this modularized test suite where one script would create quotes and store the number in a data pool, and a separate script would consume them and bind an insurance policy. But because the test generated many times more quotes than policies, I ended up with an excess of quotes which eventually became expired. So to solve that problem, I ended up actually merging my quote and bind scripts into one, getting rid of the data pool altogether and replacing it with a correlation rule. And I added some logic which said a certain percentage of the time, get a quote and then go ahead and turn it into a policy. So those are some challenges, and I'm sure there's many, many more, but we'll just start with that. And let's talk about some of the solutions that we can use to overcome these challenges. Number one, if you can avoid having to build and maintain a data pool in the first place, do it. Less data pools means less technical debt, provided you do this without significantly hindering realism. It's going to save you time and complexity. Number 2, where it's appropriate, correlate data instead of creating a data pool. So many applications have some kind of auto-populating drop-down lists, or have a series of links to pick from, or there are APIs which provide a list of suggestions. So you can use this to your advantage to remove the need to have a data pool in the first place. But once again, make sure you consider realism. Number 3, learn how to generate synthetic data using your load testing tool. For example, JMeter provides functions to generate dates and times, random numbers, and random strings. So whatever your load testing tool is, learn how to achieve this, and it will often involve writing some code. Number 4, understand the solution under test, especially caching, and the data dependencies between systems. For example, maybe the customer numbers in one system need to match up with those in another system, that kind of thing. If you don't understand this and haven't accounted for it, then it could cause you all kinds of problems later on. Number 5 is understand the business context. This will help you understand how data flows through the application, and it might help you design a more effective or simpler test data approach. For example, I know in insurance we have customers who quote for insurance. Those quotes sometimes get purchased and become insurance policies. Customers can make claims against those insurance policies. So knowing this helps me build a picture of not just the test data I will need and how it all connects, but also the test suite itself and how I might design it. Number 6 is to aim for a sustainable test data lifecycle during your tests. So that's a bit of a mouthful, but in other words, the load test itself creates its own data so that you don't need to prepare anything in advance or process anything after your test if you can avoid it. If you can avoid having any special scripts to run before or after your test, it'll make your life so much simpler. So you model your life cycle off the real world. For example, a test which creates customers who create insurance quotes and so on, like I just talked about. This requires understanding the business processes of your solution. I actually had a situation a couple of years ago when we had a load test suite which had one script which was creating data records based on real world volumes, and some other scripts which would consume those records. And what we found is when we used the workload model from the real world, we were running out of records because they were being consumed too quickly. So in that situation, we modified the workload model of our test so that it was creating enough records so that it would be sustainable. So we compromised on realism a little bit to have a much simpler and easier to manage test suite. So we significantly reduced the technical debt there. And sometimes it's absolutely worth doing that kind of thing. Number 7, stubs can make your life easier. So if a system under test, which validates vehicles, for example, is stubbed out, then you might be able to get away with using the same vehicle for all of your performance testing. But you need to make sure you've thought about the applications which are not stubbed and what this means in terms of realism. So I recently came across an issue where there was a stub which always returned the same 6 or so vehicles. However, the vehicle registration number turned out to be used as part of the search criteria for some other process. So because our performance tests were creating thousands of customers with the same vehicle, it triggered a false positive performance issue in the database. So you've really got to watch out for that kind of thing. Number 8, if you do have to have some kind of process before or after a test to manage your test data, automate it. For example, I automate the querying of databases to get test data and then transferring that data from one place to another or inserting it into a database or whatever it is that I need to do. This is that kind of repetitive churn type work, which is an ideal candidate for automation. It'll make your life easier. Okay, so those are the solutions I wanted to talk about today. And before we close off for this episode, I wanted to raise a couple of other points. The first one is that if you manage your load test data separate from your load testing tool, it has a positive side effect of making your test data independent of your load testing tool. That means you can switch out between different load testing tools without having to touch your test data, which can only be a good thing. So this isn't a must-have at all, but it can be a nice thing to have. So I mentioned earlier, I created my own tool. It's a Node.js application. I just call it the Data Pool Manager, and it sits on a server somewhere in our organization, and it runs 24/7. And you make HTTP requests to it in order to retrieve data or add data or delete data. And so any load testing tool can use it, because all load testing tools can make HTTP requests, right? Also, because it's just sitting on a server somewhere and running, other teams can utilize the same Data Pool Manager instance. At the moment, there is no user interface, but I would like to add a web interface where people from all around our organization can just go to a website, add the data pools they want, or manage them, to provide a kind of self-service performance test data management solution. That's where I'm heading with that one. And lastly, just because it's really interesting, I wanted to talk about Paul McLean, who's a performance engineer in Melbourne, who's created this really interesting, completely synthetic Australian census data. So you can use that for registering customers on an application that you're testing, and they all have email addresses which you can interact with via APIs. It's really interesting stuff. And if you're interested, then definitely check out Paul McLean, who's fairly active on LinkedIn and has a YouTube channel. That's all from this episode of Performance Time. Thanks again for tuning in. And as always, this is Performance Time.